Okay, hi everyone. My name's Matt Groves. I'm a creative developer, and I'm a co-founder of a company called Goodwill Digital that basically specializes in making rich web HTML-based stuff. And I also created an open source 2D renderer a little while back called Pixie.js, which is handy because I'm going to talk to you guys about 2D on the web. So let's begin. So what we're going to talk about today is the 3 different ways in which you can render 2D on the web. So we will talk about WebGL, but there's also the other ways, Canvas and HTML. We'll talk about the pros and cons of each one on a high level. Then we'll compare performance and the code to sort of get the 3 different ways running. Then we'll look at some of the cool 2D WebGL effects you can do that you can't really do in HTML and Canvas. And after that, we'll look at a couple of the cool technologies that are going to be present with us soon that will make all this sort of rendering stuff a lot easier and a lot more fun to do. Okay, cool. So we can start off with rendering with HTML and CSS. So one of the great things about HTML and CSS is it's declarative. So you set your structure with HTML, and then you say how it looks with CSS, and that's a really nice way to make things, and people find it kind of quite easy to get their heads around it, which is great. It's obviously amazing for SEO, so Google can see it. Search engines can find all of that content in the structure, and people can find it, which is great. SVG is always really crisp and lovely when you're rendering with HTML. And then you also get a lot of like text rendering in HTML is also really amazing. In Canvas and WebGL, it's always like there's always sort of tricky, painful points, whereas when you're using it in HTML, it just flows, it kind of just works. And also you can do things like copy and paste, which is really handy for websites. And WebGL and Canvas, you can't really do any of that stuff. The other thing is it's generally, if it's a static website, which most websites tend to be, then they have really good energy usage, and the battery consumption on them is usually quite good. The downside of HTML, and this is in comparison to the other things, is basically performance isn't quite as good as the other 2 methods. So the second method is rendering 2D with Canvas. So that has a big advantage of the fact it's basically, just for those who don't know what it is, it's basically, essentially you get given a big bitmap, and you can draw things to that bitmap. And it's got a really simple API, it's really easy to learn. You sort of just say, draw an image here, draw a shape here, and it's really nice, really clean, really easy to pick up. And it's also much faster at rendering than CSS, so you can get thousands of objects rendering on Canvas, which is great. And also you can have as many canvases on a web page as you want. You're not limited, like the next one. The con is super black boxed, and for SEO it's pretty much useless. So whatever you're rendering inside that canvas, if it's text and images and loads of cool informative stuff, basically when Google sort of searches and looks on it, it just sees an image and it can't really go inside and do anything with that. So it's basically, like I say, black boxed. It's also limited in scope because it basically does only draw shapes and images, which is good, but sometimes you want to do a little bit more. And then the other con is it's not quite as fast as the next method, which I'm hoping people have heard of, which is WebGL. So obviously the pro of WebGL is it's super, super fast. You get loads of flexibility with WebGL. You get basically you create these things called shaders, which you can basically tell the GPU what to do and how to render. So you get a nice low-level control, and with that you can do lots of amazing, powerful things, and especially for 2D as well. Even though WebGL is generally looked at as a 3D engine, it's kind of a 2D API that happens to be very good at 3D. So we like to leverage that for 2D as well. But it's not perfect. One of the downsides, and the main downside, is it's really, really complicated. It's got a really steep learning curve, and even now I don't feel fully 100% confident working with WebGL, and I've been playing around with it for years and years. So it's a completely different way of thinking to the traditional ways of rendering with the web. It's also a bit of a power hog. So if you're starting out using WebGL and you're going to be like, oh, I'm going to render all my sprites in WebGL, this is going to run really quick. If you just do it out of the box the way that all the tutorials will tell you to do it, it will be slower than Canvas, and it will probably be slower than rendering in HTML as well. So if you get it wrong, it will be worse than the other methods. Another con is black boxed as well, so it's hard to index, so it just looks like an image to search engines. And then another limitation is you can usually only have about 4 per page, which can be a problem. So when would you use these different methods? So in a really high level way, I think if you're delivering information to your users, so if you want to help them book a flight, help them buy something, get information into their brain, then it's a no-brainer that you're going to use HTML and CSS, which is why most websites are HTML and CSS. So that makes total sense that that's the way it goes. I think if you are trying to do something slightly different, so instead of giving someone information, you want to kind of punch them in the face with an experience and make them feel a feeling, then WebGL and Canvas are really good for that because they're focused on giving people really nice visual impact. So games are a really great example of that. A game isn't information-driven. You don't play a game to learn something. Well, some games maybe, but most games you play for fun, so you play for that experience. And also data visualization is something that WebGL and Canvas are really, really strong for because they can just move loads of things around, which is handy. And often when you have to pick between Canvas or WebGL, I think Canvas is often enough for smaller animation things. So if you've got like a big website and you've got lots of just neat little bits of animation that you want to see, I think Canvas is good for that. There's no point using WebGL unless it's a big meaningful thing. Otherwise, it just takes up loads of memory for no real reason. Cool. So I guess the other cool thing is it's getting pretty modern that people will mix and match the strengths of both. So you'll often see a really nice HTML website that's written in HTML and CSS, and you can kind of get all the information, but then it's usually got like a high-impact piece, like maybe a nice background or a nice header, which I'm going to show you this site because we did just that. We basically made the Pixie website, and it's all just standard HTML, CSS, but we just made a really cool little attraction thing at the top just to get people excited about what it was. And I think that's quite common amongst websites now to kind of hit them with some nice experiential piece of content while you're delivering them the information. OK, cool. So let's look at rendering with these things and how they perform. So this is kind of pseudocode. I'm going to show you guys a little space scene, and we're going to throw some rockets across, and we'll see how many we can get on screen. So for HTML, basically what I'm doing is I've got a bunch of rockets, and each one has a position, which is just an XY object. And then it's also got an image, which is just a DOM element image. And then I loop through, and I just say, hey, set the image transform to be this position X, this position Y, every frame. And then those positions are changing with some code. OK, so here we go. So this is a CSS run, so hopefully you can see the little 60 FPS, and that number there is our counter. The ships look a bit like carrots, so sorry about that. What happens when I make pictures. OK, so see how many carrots we can get on screen. So you can see we've got like 1,000 spaceship carrots, and we're running about 40, 30 FPS. So if I keep going, you can see like once you get to about 17,000, 18,000, we're about 30 FPS, which is quite cool. That's a lot of things moving around on screen. So that's where I guess CSS is good for that. So that's our performance there. And then if we move to looking at how Canvas renders, so we basically get, with WebGL and Canvas, you create a canvas element, and then you get the context. So for regular 2D canvas, we get a 2D context. And basically, once we've got a context, same thing, we're looping through our rockets. But instead of attaching the image of the rocket to the DOM, we just go, hey, context, almost stamp this image at this XY coordinate. And then we just show that big bitmap on screen. So if cool. So what do we get to? We got to like 1,700. Oh, no. Yeah, about 1,700. So this is Canvas. So if we get to like where we were before, you can see we've got like a few more carrots than before, and it's still running at 60 FPS, which is really cool. But let's see how much further it can go before it starts to slow down. There's more, if these ships were defending Earth, you'd be very, very safe. OK, so 6,000. So there's like more than enough to do some really cool stuff, right? There's a lot of power here. So we get to like 7,000, 8,000. Okay, you get the idea, right? And we're still above 30 FPS, and that's quite a big difference between CSS and Canvas. So you can see sometimes, like if it's about moving things around, this is a really good choice for that. OK, so let's move on to WebGL. So this is the code for rendering WebGL, part 1. part 2. There's a missing image there. It broke for some reason. Part 3 and part 4. And all that does is basically draw a triangle on the screen. To actually do all the rockets, it's like 10 more pages like that. So it's just there to show you guys that it really is like not as straightforward as the other methods. But once you get past all that and you want to protect Earth with carrots, what you do is you use WebGL. So we got 8,000 there, and if I, OK, so this is the WebGL one. So we had 8,000. Cool. So now we've got 8,000 at 60 frames a second, which is pretty cool. We're very well protected. But let's see how much more we can do. We've only got 20 minutes. I've capped it at 100,000. Otherwise, we would literally be here all day. So there we go, 100,000. 100,000 sprites at 36 frames a second, which is crazy, right? So that's why WebGL is awesome, because the power levels are like, OK, pretty good, out there. And not that you need that many things on stage, on your screen, but if you're developing a mobile app or something, then you can imagine that the very fact is it's just the amount you need is going to use less energy, less battery, so it's a really efficient way of rendering on screen. Cool, so I'm going to try and explain WebGL on a kind of a higher level way of how it kind of works. Like say, if I was to actually sort of do a talk about how WebGL actually works, we'd be here all day, and that would be pretty much all we talk about. So WebGL is basically, the way it works is it likes to have everything as generally triangles. So you create a bunch of triangles, and you send them to the GPU. And so in this instance here, we've got this is how we'd render a sprite on screen. We just send it 2 triangles, and then the triangle gets filled with a texture, which is our little character. And if I wanted to render something a little bit more complicated, I'd basically triangulate it, turn it into a bunch of triangles, and go, hey, GPU, draw those triangles. And the way it draws those triangles is by using something called shaders. And they're basically the little programs that we write and we send to the GPU. So we go, here's some shade, use this shader, here's some triangle information, and then it will pop them on the screen for you. So the first a shader is basically broken down into 2 parts. The first part is called a vertex shader. And a vertex shader basically has the responsibility of taking all those triangle points, all that information, and sort of positioning it and turning it into screen space, essentially. So it figures out where the triangles are going to go. And then once it's done that, it sends that information to another shader, which is called the fragment shader. And the fragment shader's responsibility is to essentially, as it draws a triangle to the screen, every single pixel in that triangle basically gets a fragment shader program run on it. I haven't actually got an example code of what it looks like, but it's written in something called GLSL, which looks a lot like C, so it's a separate language from JavaScript. Cool. So obviously, you can do lots of carrots, which is really great. But the other thing you can do is you can mess around with vertex shaders and fragment shaders to achieve cool effects. So basically, one of the things you can do is mess around with fragment shaders. And with fragment shaders, you can essentially make filters from real-time filters. So a filter is basically one of those things that we've probably all seen in Photoshop and After Effects and Flash 100 years ago. So filters, if you basically what you're doing is you're running code on every single pixel, every single frame. And if you were to run that on the CPU, you'd have, say you had a 1024 by 768 image, that would be 786,432 pixels that you'd have to run a piece of code on every frame, which is bonkers, right? Because if your computer did that, then it would, unless it was like a supercomputer, it would just burst into flames and run really poorly. But instead of that, you tell the fragment shader to do it. And on the GPU, the fragment shader is very fast. So I'll show you guys the little, this is my little Pixie filters demo. So this is what fish would normally look like. But what we can do is we can add a filter. We can basically, when we're rendering these fish to the screen, we add a filter. So basically, they're running through a displacement filter just to make them feel like they're in real water instead of super clear fake water. So there you go. And then we've basically got loads of filters here as well. So I'm going to use my amazing design skills to improve this dramatically. So I think a blur will look really cool. And then inverting it definitely looks cool. Then pixelating it. And twisting it, that always makes things look better. And then we'll add a dot screen. And then to finish it off, we'll add a crosshatch. So as you can see, you can do amazing design things with fragment shaders. Okay, cool. So the other thing you can do is you can mess around with the vertex shaders. So that's basically the triangles themselves. So you can keep the fragment part the same, and then you can go, I want to move my triangles around in a more interesting way. So most of the time, so this is my little snake, which we use often for examples. He's like just a normal image, but he's constructed of these triangles. And then we're moving these triangles around, and he kind of can move around with it. And you end up with getting some really nice effects that you can't really achieve in any other thing. So this is the snake. So he's just a straight image, but the way that we move him around just kind of makes it a little bit cooler, a little bit more visual interesting, and makes him a bit more friendly as well, I think. I've got a slightly cooler example of using the same technique, which is here. So this has kind of got a few extra layers of stuff mixed in, but this has like got a bit of physics in it. So as I move my mouse around, they kind of like move around with some physics, but the principle is the same. Like the lines figure out where they need to be, and then the images are just straight images, and they basically get distorted to bend and just kind of look cool. And obviously the cool thing is because this is GPU based, you can have like loads of them, and it doesn't skip a beat. It's just like, yeah, cool, throw more at me if you want. So as you can see, shaders are awesome. But that's not all you can do with shaders. You can also steal things from 3D, which is really great. So on the right, we have our sprite sheet, which is just a bunch of presents for someone's birthday. And on the left, we have what's called a normal map. So basically, a normal map, instead of in the pixels, instead of in the red, green, blue channel, usually we store color, like on the right. We're storing the direction of light. So it's all direction of surface. So it's basically saying if a light hits me at this angle, this is how it's going to bounce off. And what we can do is we can send both of these to the GPU and write a shader that basically can compute lighting in real time. So it's still 2D, but it basically it's like a really nice lighting effect. So where's that? That'll be here. So this has the same sprites that we were just looking at. And then this little mouse thing here is basically the light source. So you can see basically as I move around or as the presents move around the light, you get like a much more rich 2D thing. So there's no 3D going on. It's just the lighting just makes it all look a lot more visually interesting. There's also some other stuff on here, like the shadow casting. Again, because we've got loads of CPU power left over because the GPU is doing all the hard work, it meant we could write a little shadow caster on there, and it still keeps a really nice frame rate. There's also a little icy displacement over the top of it all just to seal in some flavor. Okay, cool. So the next thing I want to show you guys that you can do with WebGL that you can't really do with anything else is basically writing data to textures. So this is the most confusing one to explain. Basically, usually you just use textures, and in the red, green, blue alpha channel you have color information, but you can actually store like full floating point numbers in there instead. And what you can do is tell the GPU to basically do work on those numbers. So essentially, you can move some very specific types of computing to the GPU by using float textures. One of the things that you can do, which is one of the coolest looking things, is basically sort of fluid, smoke, dynamics, all that kind of stuff, because they lend themselves perfectly to being worked on the GPU, because it can basically all be done in parallel. So when you're calculating the movement of one piece of fluid, you can another piece of the GPU can be calculating another piece of it. So it means because it's all running in parallel, it's super quick. So the GPU can not only render the fluid itself, it can also be the fluid. So I wish I could say I made this, but I didn't. It was a guy called Pavel Dugret on GitHub. It's been doing the rounds, and I think it's just one of the most coolest, beautiful looking WebGL things I've ever seen. So you can see basically as you move around, you get this super nice real-time fluidy thing. And the only reason we can do that, and I'm sure you can see, like, there's no way you could do this on the CPU, but because all of it's happening on the GPU, it means that, like, yeah, it doesn't skip a beat. It just looks really, really super cool. And there's literally no way you could do that without using WebGL. Okay. So what 2D WebGL rendering engines are there out there? There's two main ones, which I would highly recommend both of them. They're really solid. They've been around for a little while. This one is Pixie.js, which is I'm a bit biased too, I'll be honest. And then the other one is Create.js, which is really amazing as well. So they've both got like mature APIs, and you can basically, instead of like cracking open the GPU and having to do all that crazy-ass WebGL code, you can just go, hey, create a sprite, add it to a scene, and then these two engines will just take care of it for you. So if you want all that power, then and you want it straight away, then these are the good engines for 2D. Obviously, for 3D, there's lots of other great engines like Babel and 3JS that you guys could look at, but for 2D, these ones could be the one. There's also a lot of good 2D engines hidden in game engines as well. So something like Phaser is a really popular HTML5 game engine. That inside it has its own custom renderer as well, which is really good. So most 2D renderers seem to hide inside game engines, which is a shame because they're really cool. One thing, if you are visually minded, so if this kind of stuff is like, oh yeah, I want to add this to my website, which, like I say, it's not for everyone because it's very much a creative coder thing, but if you're interested in this stuff, it's so worth learning WebGL, because as you learn it, it doesn't mean that you're going to make your own engine and reinvent the wheel and do everything from scratch, but it means that when you're picking up these tools, you know how they work underneath, and you know how to optimize, and you'll know how to make the most of them, and you'll be able to push them a lot further than someone who doesn't really understand what's going on underneath. So I would massively encourage you all to dip into WebGL if you're visually inclined. If you're not, then it's just a waste of time. OK, cool. So I'm powering through this talk. Future of using the web. So there's two things I want to talk about, which I think are going to be super exciting technologies that aren't really here yet, or they are kind of on the horizon. I was going to have a slide about WebGL 2, but that's kind of already here. And the reason it didn't make the cut is because this is kind of focused on 2D. And to be totally honest, it didn't really bring anything of that much value to the 2D world, because WebGL 1 is so good at doing what it needed to do. And there are some things which, in principle and on paper and academically, should be faster in WebGL 2, but it seems that because WebGL 1's been around for so long, they just went and optimized the hell out of WebGL 1. And so even though you're doing something which on paper is slower, it's faster than doing the fast thing in WebGL 2. So eventually that will balance out. It's just because WebGL 2 is quite new. So that didn't make the cut because it doesn't bring enough to the party. But WebGPU definitely does. WebGPU is basically, so WebGL 2 is like a step forward in hardware rendering, and WebGPU is like next generation. So graphics cards have moved on a lot since the days of it's OpenGL ES2, which is what the WebGL API is based on. And graphics cards have moved on a lot since then. They're way more powerful, way more flexible. And to handle that, all those new modern GPUs, a lot of new APIs have sprung up across the industry. So you guys have probably heard of them. Apple has one called Metal. Microsoft has one called Direct 3D12. And Kronos has one called Vulkan. So WebGPU is like our very own one of those. It's not actually like WebGL is literally trying to copy OpenGL, whereas WebGPU is its own beast. It's a new API. It is heavily influenced by the ones I mentioned, but it's its own thing designed for the web. And that's going to be huge, because that's going to be much faster than WebGL. It's going to give us more control over the GPU. It's going to allow us to render more effectively and achieve way more than we can now. And we can already achieve a lot, so it's just going to push a high bar even higher, which is really exciting. And the other thing which you'll be able to do is kind of a bit like the fluid example. You'll be able to compute more than just graphics. So you'll be able to use the GPU for some number crunching of different kind of things that aren't just rendering related, which will be really handy for some applications. Currently in Chrome, its status is in development. And I know that Safari has a sort of in development version as well. So everyone's working towards it, and it's going to come. It's not there yet, but definitely one to keep an eye on. You'll also all be pleased to know that it's going to be at least as complicated as WebGL. So that's something fun. Get to learn it all over again. And then the next one is something called WebAssembly, which I'm assuming most of you guys probably know what that is. It's basically a new type of code that can run in browsers. It's like low level. It's a very low level language, and it runs apparently at near native performance, which is crazy. And it's designed to work with JS, not kick it out the door and replace it, which is good. And to basically create assembly code, you don't actually use JavaScript. That you use another language that can basically compile to WebAssembly. So common ones are things like C++ and Rust. They're popular choices, and I think with Rust as well, like WebAssembly is like first-class thing. It's what it's meant for, or one, along with the other outputs. So that's pretty cool. And then for people who don't want to have to pick up a whole new language, because we love JavaScript and it's cool, there's one called AssemblyScript, which is they're kind of experimenting with the idea of TypeScript to WebAssembly. And I've seen it's still early days, but that seems like it could be quite cool because it's not going to be a big jump, as big a jump as say JavaScript to Rust, which would be quite the leap. So that's a project I'm definitely going to keep an eye on because I think we're going to have to remake parts of our engine to make the most out of that. Because one of the bottlenecks of rendering 2D on the web is that a lot of the time it's the transform, like figuring out where things need to go on the screen. And that's done on the CPU. So if we could write that in WebAssembly, it means we could write it in a lower level language, which means it would run faster than the sort of JavaScript counterpart in theory. So we haven't done it yet, but hopefully that's the way it would be. But the cool thing is because WebAssembly code can talk with JavaScript code, the dream is we get to keep all of the high-level API stuff. So if you're working with these engines and we want to keep all of that nice high-level bits, but underneath, and the bits that no one cares about, that no one touches, like the core metal bits, we can rewrite just those bits. So we get to basically have our cake and eat it, the flexibility of JavaScript and then the extra boost of WebAssembly. The other cool thing, I guess, about WebAssembly comes the ability to make things for the web that aren't made in JavaScript, which is quite interesting. I think that just means there's going to be loads more options for us all to get our stuff out on the web. Unity is a really good example of this. They've got, you've been able to publish things from Unity to a WebGL output for a while, but it's been quite big and it's not really worked on mobile that well. But they're working on this new thing called Unity Tiny, which is sort of designed with the web in mind and sort of making peace with the fact that the web file size is a concern and things need to be small. So this Unity Tiny is definitely one to keep an eye out because it means you'll be able to make something in Unity, hit the publish button, and then it's actually like a nice small piece of web content, which is really exciting. And there's loads of other engines out there which are following this approach. So the longer we wait, the more cool ways we're going to have to get stuff into the web. Cool. So yeah, I hope this stuff has got you as excited as. Oh, that's it. Yeah, it's got you guys excited about the future of the web, and as it sort of gets me. I think there's going to be more opportunities to make cooler and cooler things. And one thing that I keep seeing, which I think can make us all really happy, is that everyone seems to want to be on the web. It's the place to be. It's the hot place right now, which is really great for us because we're already here. Thank you.